Okay, we have to take another integral from the MIT Integration Bee from 2024, problem 9. We have the integral from 0 to 2 pi, sine x plus cosine x all to the 11th dx. Okay, I thought this one was really interesting because I know I've done a few like this, but this one's a little bit different. It kind of covers a case that I haven't done yet. So to get started with this for my first step, actually what I'm going to do is break this up into two integrals on the bounds. So what we'll do for the first integral, we'll just go from 0 to pi of this, all this same stuff right here. And for the second one, of course, we'll go from pi to 2 pi because we don't have a choice. We need to cover the whole bound. So again, the same thing from pi to 2 pi. And what I want to do for now is we'll just leave this one the way it is. We'll come back to that one. But for this second one, what I want to do is I want to do a u substitution. I want to adjust the bounds. What I want to do is get these bounds back to what we have over here. So I can do that if I just do my u substitution and I do x minus pi, right? That's going to get me back to 0 and pi here. So let's just get a derivative so we can do this. So for du, that's just going to derivative of pi is 0. So here we're just going to have derivative dx. And then we'll do this one off to the side. We'll come over here and do it. So doing the substitution, we plug 2 pi in here. We're going to get just pi for the upper bound. We plug pi in. That's just going to give me 0. And then let's do the rest of this stuff. But actually, let's get a value for x. Just solving for x, we're going to have x is equal to u plus pi. And then we do the substitution. We have sine u plus pi. And then for the second one, we're going to have cosine u plus pi, of course. And then this is all to the 11th, and we'll sneak in a du. But then we have identities that we can use for this and this. It's very easy to see this from a graph. If you shift sine or cosine by pi in either direction, plus or minus, you're just going to get the negative of it. So this is going to be minus sine u, and this is going to be minus cos u. But then when I rewrite, I'm actually going to factor a minus out, so I can have it like minus sine plus cosine. Yes, we'll have it like this, but this is going to be like a minus 1 raised to the 11th power. So rewriting this, minus 1 raised to the 11th power is going to be a minus 1 in front. And then we're going to get back, we're going to have this sine u plus cosine u to the 11th du. But now I can bring the minus sign out front of the integral, right? So we're going to have minus sign there. And then what I'm going to do is I'm actually going to change the variable. Let's change this back to x because it's a definite integral. I'm fine doing that. So this is going to become, I'm going to put everything back to x. We'll have sine x plus cosine x to the 11th dx. But now let's just remember what we have here. This is the same thing as what we have over here. So let's take this and we'll plug this back in for our second integral and finish it off. Okay, so now that we plugged everything back in, we just noticed that what we have here, this is exactly the same as our first integral. So it's sort of like, we could label it, if we want to call that one I and this one I minus I. But when we do this out and we have I minus I, this just gives us our final solution for this integral of just 0. Okay, there you have it. Interesting one from MIT 2024. Thanks everyone for watching. Have a good day.